This is a dynamic microphone, but how does it work? Let's get into it. Hey guys, welcome back to RAC, where we talk all things audio production and sound. Today we are continuing our series of But How Does It Work? And we are handling this baddie, which is a dynamic microphone. Moving coil. What is going on? We're getting into it. I'm Diana Everett. I'm a singer, songwriter, producer, and RAC grad. Dynamic microphones are a staple in the world of audio engineering and music production. Dynamic microphones are renowned for their durability, their versatility, and their ability to handle high sound pressure levels. Dynamic microphones are the go-to choice for a variety of applications, from live performances to studio recordings. In this video, we'll go over their technical specifications, a breakdown of their components, as well as some applications and microphone suggestions. Let's go! So, the mechanics of dynamic microphones. At the core of dynamic microphones is a simple yet effective electromechanical process. When sound waves enter the microphone, they strike a diaphragm, a thin, flexible membrane usually made up of mylar or other durable material. Attached to the diaphragm is a coil of wire known as a voice coil, which is suspended in the magnetic field of a permanent magnet. If this sounds similar to speakers, it's because it is. Fun fact, you can actually turn a speaker into a microphone. Now back to this. When the diaphragm vibrates in response to the incoming sound waves, the attached voice coil moves correspondingly within the magnetic field. This movement induces an electrical current in the coil through the process of electromagnetic induction. Flashback to our recent video on speakers where we also talked about electromagnetic induction. If you guys want a nerdy video on that, no one commented that they did, so I'm guessing you guys don't want a nerdy video on electromagnetic induction, but it's fun. Let me know. Comments. Back to the video. The generated electrical signal is a direct analog of the original sound waves that struck the diaphragm. This signal can then be amplified, recorded, and transmitted for various audio applications. Whatever you want the sound to do, it can go do that. Alright, so let's go over the components of a dynamic microphone. Diaphragm. As we mentioned, it's made of materials like mylar or other durable material. The diaphragm is responsible for capturing those sound waves and converting them into mechanical vibrations. The voice coil. A fine wire coil attached to the diaphragm. Its movement within the magnetic field generates an electrical signal. Magnet. The magnet provides the necessary magnetic field for inducing current in the voice coil. Grill. The protective mesh covering a diaphragm. Usually made from metal, it protects against physical damage as well as plosive sounds. Housing. It's the outer shell that encases all the components. It's designed to be robust and often isolates from any sort of handling noises. So let's go over the process of converting sound waves to electrical signal. The process of converting sound waves into electrical signal in a dynamic microphone can be broken down into these easy following steps. So 1, you have the sound wave impact. Hello. The incoming sound waves hit the diaphragm, causing it to vibrate. The mechanical to electrical conversion. The attached voice coil moves within the magnetic field, and electromagnetic induction occurs, generating an electrical current. Signal transmission. The electrical signal, which is an analog of the sound wave, travels through the microphone cable to an amplifier, recording device, or mixing console. Are you still with me? I hope this video is still fun. Alright, so we're gonna go over more technical specifications, but they're kind of important to know, so stick with it, okay? So when you're choosing what microphone will be best for you, there are certain specifications that you kind of need to consider. So number 1 is a frequency response. So this defines the range of frequencies that the microphone can accurately reproduce, as well as any sort of coloration that it gives. Dynamic microphones typically have a frequency range of about 50 Hz to about 15 kHz. So this is very helpful for a lot of different sound sources and applications. However, thing to note that 15 kilohertz or 16 kilohertz is kind of gonna darken your sound a little bit. You're not gonna get those super sparkly high end at all. And the sound might actually be a bit more thin. All right, number 2, sensitivity. Dynamic microphones are known for handling high sound pressure levels. This makes them ideal for sounds with fast transients, as well as kind of just loud sounds or noisy environments. That means that they're technically less sensitive because it takes more energy to move a moving coil and the diaphragm. They won't be as sensitive to the environment, as well as they won't necessarily reproduce the high end impedance. So I will be doing a whole video on these electrical terms that I think are important for understanding our machines that we use. So impedance will be one of these terms that we will go over. But basically, this is how the microphone will react to the different amplifiers. So impedance is measured in ohms, and basically this is how the microphone will interact with different preamps and other audio gear. And of course, polar patterns. Polar patterns describe the microphone's directional sensitivity. In general, when you have a dynamic microphone, it'll usually be a cardioid microphone, and this allows for all the off-axis sounds to get rejected. So we're going to talk about a few quick applications as well as a few different microphone suggestions. Obviously, you use dynamic microphones in live situations. That happens most of the time. So we're not going to talk about live performance. We are going to talk about studio applications and some microphone suggestions for that. So the first one, let's say you have a sound with a super fast transient and you have a large dynamic range, so it gets loud very quickly. We would choose a microphone that can handle high sound pressure levels, meaning a dynamic microphone. And the typical one that you'd use on a snare, pretty much everyone's going to say it, the SM57. This is a very basic one. You can use fancier ones that sound a bit better, but depending on the tone, it's like an easy go-to, can't really go wrong with an SM7. So other application, you're a podcaster, YouTube video creator, or you're an artist who wants to record outside and do those cool live performance videos. You want clean, less environment, less ambient noise, vocals. An easy microphone is this guy, the SM7B. What's great about this microphone, this actually sounds pretty good. You get a few adjustments in the sound at the back, so you can do a little boost, a little cut, which is nice, as well as it's important to know you will most likely need to add a bit of juice. So adding an inline preamp, that's probably something you will need to do. Otherwise, you're going to pick up a lot of noise. But yeah, these guys are kind of like low volume. So normally you need to add an inline preamp. Something to consider. But these are a great microphone. Super easygoing, chill, and sound round, good, perfect for podcasts, broadcasting, any sort of live video recording. Really easy. They're fine. And they're more open than the 57, I find. And then if you want to record nice vocals, record a guitar, record even a piano if you have a pair of them, record cabs, amps, any of that, you can use the Sennheiser MD441. That is pretty good. That microphone sounds great. It works on so many different sound sources. It's awesome, looks super cool, sounds super cool, bit more pricey, but definitely super, super versatile. And for a dynamic microphone, works a lot in the same, like you can work it almost as a condenser for the different sound sources. All right, guys, that's it for this video. I hope you understand a little bit more how dynamic microphones work. They're fun. They're really, really helpful. There's so many different applications. I hope you enjoy this video. If you like this video, feel free to like, share, and subscribe. We come out with new content every week. Also, please let me know if you have any video requests, or if you didn't like this video, tell me why. I really enjoy doing these videos, so do let me know. It's always good to hear from you guys, so do let me know what it is that you like and certain videos that you'd like to see, and I will see you in the next one. Bye.